Hi everyone, welcome to my tutorials on Snakemake for Bioinformatics. In today's video, I'm going to show you how to write a Snakemake pipeline for mapping reads to a reference sequence using BWA. So these are the activities we will perform. We are first going to download the example data set. We will download FASTQ files. These are paired and reads. And we're also going to download the reference sequence, which is a FASTA file. And then we are going to index the reference sequence. After that, we will perform the mapping. So you need to make sure that you have Snakemake installed. You should also have BWA and then some tools. I have tutorials that show how to install all these tools. So check the description box, you'll find links to videos that show you how to do that. Snakemake will be used for building a pipeline. BWA will be used for indexing and mapping the reads to the reference sequence. And then the output of BWA will be converted to a BAM file. That one will use some tools. All right, so make sure to have all these tools installed. Okay, now let's open the terminal and then start the exercise. So I'll open mine now and then we'll proceed. All right, so I am on the terminal now. So on the terminal, what I'm going to do first is to activate my Snakemake environment. The quickest way to install Snakemake is to use Panda or Mamba or Macomba. Okay, again, instructions for installing Snakemake can be found in the discussion box. So let's do this. Let's first activate our Snakemake environment. So I'll say Conda activate Snakemake to activate it. That'll be the first thing. Then I'm going to do this. I'm going to cd to my home directory, and then I'm going to create my working directory. So I'll say make the Snakemake. It's going to be my working directory, and then I'll cd into it. So that will be cd Snakemake. All right, so that has been done. So now what we are going to do next is to download the example data. So let's visit this page. All right, so we are going to use the example data which was presented in this tutorial here. All right, and by the way, this tutorial here, I've covered this tutorial in one of my videos. So if you're interested, you can just check that video. The link to that video is in the description box. So we are using the data which was used here. Okay, so the link to this page is in the description box. I repeat, the link to this page is in the description box. Okay, so let's scroll down. So when we're here, scroll down, you'll get to the section data preparation. You can just click it, and that will send you to this side. You can still scroll down in case you don't see this link here on this page. Just scroll down a bit, get data, and you are going to find the links here. All right, so these are the FASTQ files. We also need the reference sequence. So we will start with the FASTQ file and then move to the reference sequence. So let's do this. First of all, we have the links here. These are the links to the FASTQ file. So instead of downloading them one by one, we will do a batch download. So I'll first copy the links. Right, so these are the FASTQ files. So I'll just copy the links, and then I'll move to the terminal, and then I'll open a text file and then place the links in them. So I'll say nano, I'll say links.txt. You can use any text editor, that's fine, but I prefer to use nano because it's straightforward. So nano links.txt, and then I'm going to paste the links there. So I have 3 samples. Okay, so father, mother, proband. Okay, so I'm using this to show you how to also run Snakemake for multiple samples. Because ideally, if you're doing analysis, it's likely you'll be using more than one sample. So you need to automate the process. All right, now we have the FASTQ files. Let's add the reference sequence. So let's go back to the page and then check the reference sequence out. We will use that also. So let's go down a bit. We are going to see the reference sequence there. So there's a reference sequence. All right, so I'll copy this also. You can also use this one here, but I prefer to highlight and copy. So I'll copy this also, and then I'll add it. So I'm going to paste it also there. So those are the files. I will just add a space here to differentiate them. So these are the FASTQ files. This is the reference sequence. So I'm going to edit and save changes, and then I'm going to download. So for downloading, you can use curl or wget. If you're using Mac OS, then you can use curl straight away, or you can also download them manually. Here, the most important thing is to download the file. So it doesn't matter how you download it. That one, I'll leave that to you. But for me, I'm going to use wget to get all the files. So I'll do this. I'll combine wget and xargs. So this is what I'm going to do. I'm going to do this. I'm going to say at lengths.txt. I bring a pipe, and then I'll say xargs /I by this. And then I'll say -p for, I'm going to use 4 processes. And then I'll type wget space, I bring a single quote, I bring my curly brackets like this, I add my single quotes again. So this goes to my final command to download the files. Okay, so let's execute this command to download the files. All right, so this will download the files for me. So I have to wait for everything to get done for me. So again, you don't have to use this approach I'm using to download. If it's complicated for you, you can just download them one by one. You can even download using your browser. So let's just check it out. Just, for example, just copy the link and then open in a new tab or open the link. So this will download the files for you. So just try any of those approaches to get the files. Okay, so I'll wait for the files to get downloaded for me. Okay, the files have been downloaded, so we can take a look at them and then organize them. So let's clear the screen. Let's do an ls. We are going to find the files there. So we have the files. So we have the FASTQ files. We also have the reference sequence. So let's organize them. Let's move all the FASTQ files to a separate directory. So I say make the FASTQ. You can also say raw reads or use a name that describes the data, right? So I'm using FASTQ. I'm going to move all the FASTQ files. So I'll say mv star.fko.gz. I'll move them to the FASTQ directory that I created. So I'm going to move them there. So if I do an ls, I'll see my directory, FASTQ. If I ls into it, I'm going to find my FASTQ files. I have 3 samples. These are paired in width. So a total of 6 files, but 3 samples. Right, now the reference sequence, this is it. We'll also move it to another directory, and then we are going to also do this. There's a .gz format, but we have to decompress it. So first of all, I'm going to decompress it first. I'm going to say gen unzip to unzip it first. If I do an ls, I'll see the name has changed. Now I'm going to create a directory called ref. I'll say make the ref. And I'm going to put that file as I say mv hj19. It's mv hj19 chr8.fa. I'll move it to ref. So do an ls, you'll find ref, and then do an ls into ref. You'll find your file there. Okay, now let's do this. So we have all the files we need at the moment, but then if you're going to perform genome mapping, you need to first index the reference sequence. Now, if you're building a pipeline, ideally you want to include everything in the pipeline, but this tutorial here, I'm focusing on just the mapping. So I'm going to do the indexing outside the Snakemake pipeline itself. So I'm going to first perform the mapping using BWA, and then after that we will write the script for the Snakemake pipeline. All right, but if you want to include that in the pipeline, you can always reach out to me. You can have a session and I'll show you how to do all those stuff. But this tutorial is for beginners, and so I prefer to tackle it one point at a time. So I'll just do the indexing outside and then we'll proceed with the main activity, which is mapping. Okay, so let's do this. So I'll first clear the screen. I'll do an ls again. I'll ls into ref, and then I'm going to now do the indexing. So to index a reference sequence, we'll say BWA index, and I'll specify the sequence. So ref slash ag19 underscore chr8.fa. So let's index it. All right, so this will take about, it will take a few seconds to complete because we are dealing with just one chromosome, so we have to wait for the indexing to get done for us. Okay, mapping is yet to be done. All right, but for now, we have been able to perform the indexing. So indexing has been successfully done. I repeat, we have now performed the indexing. So once everything is okay, you will see something like this coming up. Okay, so let's clear the screen. Let's do an ls into ref, and we're going to find additional files generated. So we are ready to go. Okay, so let's do this. Now it's time to write the Snakemake pipeline for mapping the reads. Okay. So now this is what we are going to do. If you are going to map reads to a reference sequence, you can do this. We can just say BWA, and we type mem, and then we add our reference sequence, which in this case will be HD as a ref slash ag19 this, and then we add our read 1, read 2. All right, let me just do this. Let's into the FASTQ directory. So let's say if it's father r1 r2, we can just say FASTQ slash father r1 .f2.gz, and then FASTQ father r2 like this, and then the output, which will be a sum file, we will now convert it to a BAM file using sum tools. So we add a pipe and we say sum tools view-s hb -o, and then we bring the BAM, the output name .bam, and then we bring a dash. All right, so it's something like this that we will do. All right, and by the way, I have a separate tutorial on BWA. So for that one, I explain a couple of things. So if I begin, you can just watch that video. The link to that video is in the description box. So this is the command. Okay, so with this command, there's a simple command that I'm using, but you can also add more information to it. That's for advanced users. You can read the BWA manual to get it. So it is this that we are going to use in the Snakemake pipeline. All right, so Snakemake allows you to write reproducible and scalable pipelines. And so in some situations, if you're writing a pipeline, then you can use a Snakemake to do that, so that it helps you to manipulate a couple of stuff. It helps you to automate some stuff. All right, so that's why I'm showing you how to do that, but you can still run everything on the terminal like this on multiple samples. Okay, so we are going to use this base command, and so this is what's going to happen. Let's just do this. I'll clear this. So this is what's going to happen. It's going to be BWA mem ref read 1, read 2, then sum tools view-s hb -o, then BAM, and then the dash. So dash here means we are taking the input from the output here. All right, so it is going to be the base command. All right, so we are going to do everything in Snakemake, and then you will get how that works. Okay, so I'll clear the screen and I'll proceed. Okay, so Snakemake pipeline. The pipeline is a normal text file with the instructions that we will execute in them, and so we will need to open a text file. So I'll use nano, and I'll say snake file. Now the reason why I'm using snake file is that if you use snake file as the name of the text file, then when you are calling Snakemake, you don't need to specify this file. It will automatically look for this file. It will look for the file with the name here and then execute the instructions in it. But if you use a different name, you have to specify it when you are calling Snakemake. So this one simplifies it for you by not specifying it. So let's all use this one, and later you can make changes. So we'll open it now. Okay, so I've opened it. So in Snakemake, activities that are supposed to be executed, you put them as rules. All right. And by the way, before I proceed, let me send you to this page. I think it will be good we look at it. So this tutorial here is also one that has been designed for beginners. So it has tutorials for mapping and stuff like that. So it's what I'm doing is supposed to complement what has been given here. So you can check this out, and you can also follow my tutorial to get an understanding of how to use Snakemake when it comes to mapping weights. All right. For beginners, you can also watch this one. And that's also fine. So let's get back to the command line. All right. So we have to put it in a rule. Okay. So in this activity, we are going to perform mapping. So I'll just do this. I'll just say rule. I'll say BWA map. This is going to be my rule. All right. So once I do it like this, then I will need to specify the information that is required. Because it's going to be mapping, we will need inputs, and we are also going to need outputs, and we're also going to need the command for mapping. So you are using BWA, so you issue a command, a BWA command. This command will require you to supply an input file or input files. In this case, ours is going to be file because we have paired and weights, and then we need to specify the output file, which should be the BAM file that we generate finally. All right, so that's how it's going to be. You type rule, you give the name of the rule. In this case, it's referring to the activity, which is BWA map. You bring a colon, and then you go to the next line. Then you give an indentation. So I'll use 4 spaces. 1, 2, 3, 4. And then I'll type inputs. I'll bring a colon like this. And then I'll move to the next line. And I'll give an indent 1, 2, 3, 4. And an indent again 1, 2, 3, 4, because this one is the inputs, this are under this. All right. And then I'll give the inputs. So there's the inputs. We are supplying 3 files. Let me go back here. So we will need to specify the FASTQ files. And we also need to specify the reference sequence. We will specify this one. Then BWA will take care of the rest. So we will need to do this. For this section, we are using just a single sample, and then we proceed to how to deal with multiple samples. So I will supply the reference first, because with BWA, you need to supply the reference, and you also need to supply the FASTQ file. So I'll just say, I'll bring a double quotes. I'll say ref / hg19 _ chr8.fa double quotes. And because we are supplying multiple inputs, we need to separate them with commas. So I'll bring a comma, then I'll move to the next line. And then I'll bring my spaces again, the indents. Then I'll come here, and then I'll specify the read 1, read 2. So for now, I want us to use further. All right, so I'll use further, this one here. So this read 1, so it's going to be FASTQ / and then I bring further, and then that is it. Comma again, I come again, my double quotes, FASTQ / further _ r2.fq.gz. Right. So this becomes the other input. So we have 3 inputs. Now, after you have specified the last input, you don't need to bring a comma, because that is done. Commas are used to separate multiple inputs. So this is the last one, so we don't need to bring anything. So this becomes the input. Now the outputs, you move another line, 1, 2, 3, 4. And then outputs, you bring a colon, another line, 1, 2, 3, 4. 1, 2, 3, 4. That's what I use, by the way, the indentation I use, the tab character, which is 4 spaces. And then I bring my double quote and I'll say mapped width, or you can even say BAM. That's also fine. But I'll use mapped width. Let me correct it here. It's supposed to be mapped width. So the P is 2. We have a double P here. So mapped width slash, and I'll bring the name here, right? So in this case, because we are performing the mapping for father, I'll just say fathers.bam. Then I will bring my double quotes. All right. Don't worry, we'll look at how to expand it for other samples. Then the next line, 1, 2, 3, 4, I'll say shell or shell command, colon, come to the next line, 1, 2, 3, 4, 1, 2, 3, 4. And then I'll bring my double quote first, and then I'll say BWA mem. So how do we specify the inputs here? To specify the inputs, we will need to use a placeholder. All right. So here, there's the input. So we can bring our curly brackets, and I'll say inputs, and then another curly bracket. Yes. So this curly bracket and this variable name here, these are placeholders. This is the input section. So if you want to refer to inputs in the shell, it's this format. Your curly brackets and then the inputs variable itself. And then that's it. So here the input here refers to all the files that you have supplied here. All right, all the files here. So there are ways you can also specify them individually, but we'll look at that later on. But for now, because we are using all of them at a go, we can just do it like this and then we put them here. So what is going to happen is that because we supply the inputs in this order, this is how it's going to be entered here, or going to be fed to BWA. So we have ref first, read 1, read 2, just like we did here. Let me just do this, just like we did here. BWA ref, read 1, read 2. So we have ref, read 1, read 2, because that is how we specify them here. Ref first, read 1, read 2. So Snakemake will take them and then put them in the same order. And then after that, we bring our pipe symbol and you say sum tools U-S HB -O, and then I'll supply the outputs. So the same outputs like this, and that is done. Okay. So here the output is what? Map width slash father.bam. So we don't need to supply bam or anything else. All I have to do is to bring our dash again here and then close it. So the dash here, I repeat, it's used to get the output from this command. The output here, this is the meaning. So the dash here means that we are getting the output from this, and that will be the input for this command. So the dash here, you should include it. Okay, so this becomes our final command. Now you'll notice that we have not created any directory called mapped widths. Let's check here. If you do an ls, we don't have any directory called mapped widths. We don't need to create it because Snakemake will automatically create that for us. So that is why I did not create it, but I specified it here. So the output directory will be created for you automatically. But for inputs, it should be specified. You should specify the right paths to the files that you are going to use as inputs. So this becomes the final command. So that's what we are going to do. We are now going to exit and save changes. We will come back to this file later. Right. So for now, let's exit and save changes. So I'll type Control X. I'll type Y. I'll enter and I'll type. That is it. All right. So do an ls, you will find your snake file there and you can proceed. Now, before you proceed with your pipeline, you can do a test. So let's do this first. First, let's just do a summary. So I'll just say Snakemake dash summary like this to get a summary of what I'm going to do. So I'll just type it like this, and execute. So once I do it, I'm going to find something here. So this is what is happening. You have the output file indicated. We have a rule which Snakemake identifies, and it also looks at the output for that rule, which is this one here. So this is the expected output. So the expected output, we have the rule, version log, etc. Status missing. It's missing because we have not generated the output file yet. Plan, update pending. Okay, so we should see something like this. Okay. Now, another thing we can also do is dry run. So dry run allows us to test the pipeline. I repeat, dry run allows us to test the pipeline without us having to execute it. So it's something like this. Let's look at this page again. By the way, the link to this page is in the description box. So on the mapping section, you have something like this, which is a dry run. Okay, this is a dry run. So -np. So -n is used to specify a dry run. It has been defined here. You have this and this, or this or this. And the p is used to print the resultant shell command. All right, we will look at all these things. Okay, so in addition, we are also going to specify course. I'll bring that here for you to see. Okay, so for now, let's do a dry run. So dry run, it's like this. Let's just do it. So you say Snakemake -n, and I'll say -p. Of course, the -p may not be necessary. It is this one which is more important if you are doing a dry run, but I'll just add this to it. And then let's execute this command. Let's see what comes up. Okay. So once you do it, you have this coming up. It tells you the rule. Then it tells you what you are going to get. So we have this. So there's going to be the rule. And we have this, and we have this. All right. So it says missing output fast because we have not executed it yet. And then that is it. So it's also give you some information that will help you to know what you are doing, and that's fine. Okay, you also have building DAG of jobs. This is something we'll cover in another tutorial. So for now, we are using just a single instruction, so I will skip this one. We'll talk about it later on. Okay, let's do this. Let's clear the screen. Let's do an ls again, and let's continue. Now, this is what we are going to do. We are now going to execute this pipeline. All right, so if you want to run a Snakemake pipeline, you say Snakemake, and then you need to specify a course. I'll say --course. I'll specify one. And then I'll add a -p. The -p allows us to display the shell output. If you're running BWA on the terminal, okay, you are going to get some outputs. Okay, not outputs, you are going to get a text being displayed. Let me just put it that way. If you're running BWA on a terminal, you realize you have some text being displayed for you. And so if you bring a -p, then Snakemake will also display those texts that are coming up. Okay, so that's how it is. But you can choose to omit it, that's fine. But let's add it so that we see BWA in action. So this is it. And then we are done. So let's execute this command. Okay, perfect. So now BWA mem is being executed. So we have to wait for everything to get done for us. Okay, Snakemake has completed its work. So that means that BWA has completed its work. So let's clear the screen. Let's do an ls, and we are going to find that the output directory has been created. That's mark3. So if you ls into it, we are going to find father.bam. All right. Now let's do this. We have the output. All right. So if you have the output, I mean, if it's a BAM file which contains alignment records, you can also check the mapping statistics. Let's look at that before we proceed with Snakemake. You can say some tools flag stats like this, and then you can specify the BAM file. You can say map with /father.bam. So that will give you some mapping statistics. Okay, of course, the flag starts, if you execute it, depending on the size of the BAM file, it will take some time. So we have that here. So you can just check the mapping statistics as well, and then proceed. All right, so there's something you can do after performing the map. Anyway, let's get back to Snakemake. Now let's create a screen. Let's do an ls into map read, and then let's rerun Snakemake again. Let's record the command. This time I will just recall it like this. So let's execute this command. Now, if you execute it, it's going to tell you that nothing to be done because all requested files are present and up to date. So that means that the output file is there. The expected output file is there. And so if you want to rerun, then what you have to do is to remove the file or files, and then you can rerun Snakemake again. So Snakemake tracks the output files, and then it runs again depending on whether the output file is there or not. So now let's remove the output file. We will rerun it again. I'll just say rmmap restart.bam. We are removing the BAM files. For now, it's just one, so I don't even need a star, but I'll just it as it is. Okay, so that has been done. So we can rerun Snakemake again. Now let's do this. I think I'll open something here. Okay, I think let me just do it here. I'll say nano snake file. Let's open it. Now what we did, we explicitly specified a particular sample. All right. Okay, for mapping. Okay, so that is further. But what about if you want to use other samples? Like we have further, we also have mother, proban, right? Or you may have other names as well. So how do we make this generic? How do we make this snake file generic? So we will do this. We are going to do this in stages. We will start with the simplest approach here. Now, if we want to make it generic, then there's something we have to do here. All right, so I will do this for now. Let us just, we will redo everything again. I think that will be better. We are going to redo everything again. So this time, that's what we are going to do. I'm going to use snakefile2, and I'll use that to show you how to specify a Snakemake file on the terminal. All right, so let's say nano snakefile2. This is a new file, a new snake file. All right, let's open it, and then let's just do this. Okay, I think I'm going to retype everything again. So this is what we are going to do. So we will do this. We are going to retype the rules again. This time we know what to do. So rule BWA _ map. And then I'll bring my inputs like this. Yeah, let me just go over again. Yeah. So here I did not specify the colon. It's important. Okay, so you need to specify it. So let me just redo everything again. It's part of the practice. So I'll just type rule. I'll say BWA _ map. I bring my colon. Next line 1, 2, 3, 4. I specify my inputs. I bring a colon. Next line 1, 2, 3, 4. 1, 2, 3, 4. For ref, let's put it in quotes. So I'll just do this. Ref /ag19 _ chr8.fa. Like this. I bring a comma. Next line 1, 2, 3, 4. 1, 2, 3, 4. Let me just redo it again. Bring double quotes, and then this is where we make it generic. All right, so Fastkill, the name of the directory, that one we've done it. So to make it generic, you need to use a placeholder, and that's where naming conventions will come in. So here we see that our samples are like this: sample _ r1, and then the file extension. Sample name _ r2 file extension. The same format for all of them, right? So that's uniformity. So because we have it this way, we can just use a placeholder. So I can just say something like this, sample, like this. I can say r1.fq.gz. All right, so this here, right, will represent the sample name. So in this case, father or mother or proband. So we have it this way. So we can bring our double quotes, comma, and then the next line, you say fastkill slash sample like this underscore r2.fq.gz. All right, and that is done. So this becomes what? A placeholder. So we are now making this snake file generic. Now let's move to the next line. Outputs. We bring a colon. And then the next line, just like we did it, you bring your double quotes, mapped underscore reads slash, and you bring your sample again. And this time you say dots, bam, and then you bring your double quotes. So this becomes the inputs and outputs definitions, right? Now we bring our shell. That one you know the drill already. And the shell, we bring your double quotes. That will be what? BWA mem. You bring your inputs, and then you bring your other commands or other options. So this time it's going to be some tools, right? So some tools u-s-hb-o, and then you say outputs like this, and then you bring your dash, and then you close it. So this becomes the command. So this becomes a generic command that you can use. So we can specify father or BAM, or father or mother or proband. So we have them here, father, mother, proband. You can specify any of them here. We will look at all these things. So let's proceed. So this becomes the command, which is now generic. So we can change what we need here and then proceed. All right. So this is what we are going to do next. Let's save the changes and then rerun. So let's exit and then save the changes. All right. So now that's what I'm going to do. Now we are going to rerun it. This time we are using snakefile2. That's the name. We have snakefile, we have snakefile2. All right. So you can reuse any of them. But for now, it's just snakefile2 because snakefile2 is generic. So that's what we are going to use. Whenever we make any major change, we are going to give it a different number. It's a way to also keep track of your scripts and pipelines so that if there's the need to reverse to an old one, you can quickly reverse to the previous version. Okay, so let's do this. Okay, so now we will do this. We are still going to get a summary, and we are also going to do a dry run. And so to get a summary, that's how we do it. We will just say snakemake, that's just summary. And this time, because we are using snakefile2, that's a file, you have to say -s snakefile2. So let's execute this command. All right. Now, if you execute it, you are going to see this happening. All right. So this is happening because snakemake still does not get an information. Okay. So the information here refers to the output. All right. Snakemake, what happens is behind the scenes, snakemake, when you run it, it looks for the output and then the inputs. All right. And then it sees if the output can be generated from the inputs. All right, so it needs the information that's it's needed in this situation. It needs the inputs as well as the outputs, and it will just try to do the math. Let me just put it this way. All right, so let's do this. So here it says target rules may not contain wildcards. Please specify concrete files for a rule without wildcards at the command, or have a rule without so and so. All right, so here what is happening is that we need to supply information that Snakemake will use. Now it's generic. Let me just display it here. It's generic, and so because it's generic, what output are we referring to? Father or mother or proband? How do we get that information, right? So there's a trick to do this. We will come back to this one. There's a trick to do it. Let's go to the page again. So this is the trick. All right, we will do it here. So we can specify an output, which in this case here says a.bam. So we can say father.bam or proband.bam or mother.bam, and then that will be used to get us what we want. Okay, now with the first script that we wrote, all right, we can still make changes and start, but we are still using the generic one. Okay, we've made it generic. Okay, so yeah, let me just look at this section here. So it says generalizing the read mapping. So if you are doing the summary, then you can just say b.bam or father.bam in this case, or mother.bam, or you can also say proband.bam, and then Snakemake will use that to get all the necessary information, and then that will be displayed for you. The summary will be displayed. So it's something similar that we are going to do here. So if you call the script, you just say mapped underscore read slash, let's say father.bam like this. So if you execute it like this, let's see what happens. So we see what is happening here. So we have the information here. So if you look at our scripts, this is $sample, that is the name, and then the output is $sample.bam. So Snakemake has been able to split. We have .bam, which is here. Let's just check. So it has been split, and when you split it, this becomes our sample name. Okay, so Snakemake does some processing and it identifies that yes, this file can be created, and then it gives us the summary, right? You can also try with mother.bam. And then when you do it, you will still get something shown for you. That means that in principle, this script can work. You can also try with proband.bam. And then that will display it for you. So in principle, this can work. All right. So this is the summary. Now let's do a proper action. All right. Let's try to rerun Snakemake again. And then this time, instead of using father.bam, because we had already deleted that, we have deleted it by the way, let's use a different output. All right, let's use a different sample. Let me just put it that way. So I'll say Snakemake dash course 1. I'll say -p, and I'll say -s to specify the snake file. This time we are using this one, snake file 2. That's why we need to bring -s and specify it. If you don't bring it, then it will still use the old one. It will automatically use this one here, but that's not what we want. We want to use this one here. So we say snake file 2. And then this time we will use this same format here. We will specify an output like this one here, this or this or this, any of them is fine. And then we can run it. So let's say mother.bam. It's going to be mapped reads rather. So we're going to be mapped underscore reads slash mother.bam like this. So you realize we don't need to specify even the inputs. We are specifying just an output, and then Snakemake will just get that information based on the instructions in the snake file. So let's execute this command. Perfect. So once we do that, Snakemake automatically gets the information. So now you see that is the rule. So the rule that we have here is what? Ref, we have mother, and then mother again, that's I1, I2. Even though in the script here we did not specify anything of that sort, but because we made it generic, so we made the rules general, and because of these placeholders, Snakemake automatically gets all the needed information, and then we have our command. So this becomes the final command, which is here. So this command, you can even run it outside Snakemake. It's going to work fine for you. Right? So that's the power of Snakemake. So for now, what we have to do is to wait for the mapping to be done, and we can proceed. Okay, so mapping has been done. Let's clear the screen. Let's do an ls into map reads. We are going to find mother.bam there. All right. Now let's try this also. You can also try this approach. You can just specify 2 samples like this, then this as well. Okay, but let's do this. Before we proceed, let's do this. Because we are rerunning snake file, we are rerunning Snakemake a lot. Before we rerun, we need to make sure that we have cleaned the output. Okay, that means that we need to do an rm map read star.bam like this. So I'm going to remove it first, and we are going to rerun. Right. So this activity is a clean activity. All right. So you can also add this. You can add another rule in the snake file itself, and then whenever you call Snakemake, you can specify that rule to do the clean, aka remove the files. Okay, so that's something you can also do later on. But for now, I will do the removal outside Snakemake. But it's a rule you can add, and then that will also make your work easier, especially if you are going to be removing multiple files or different files. So you can add this rule to it, and then you can just do that. So let's do this. Let's do this. I think I'll just add it so that I'll use that to show you something. So I'll add it. I am going to update this script. All right. So I'll say nano snake file 2, and then I'll do this. So I'll move to this line. I'm just going to put it at the last end, right? I'm going to say rule clean or rule cleanup. Let me bring it here. Colon 1, 2, 3, 4, and I'll say shell. Colon 1, 2, 3, 4, 1, 2, 3, 4. I'll say rm map reads star.bam. Right, so this rule does not have inputs and outputs. Okay, so this is also allowed in Snakemake. Right. So I'm going to edit it like this. And so if you add a BAM file in it, you can still issue that command to do it. So for now, let's do this. Let's just create a dummy BAM file. I'll say touch map read slash, let's say file.bam. Okay, so now if I want to call Snakemake and then specify a particular rule like I did, I can just say Snakemake, I just calls 1 as s snake file 2, and I'll say cleanup. So let's execute this command. Perfect. So it has been done. So if I do an ls, let's clear the screen. If I do an ls into the map reads, there'll be nothing there. So that rule works, right? So that's how we do it. Okay. So we are going to proceed, but you should also be careful. All right. Let's just display it. Let's look at this. Let's do a cut. Let's say snake file 2. You should also be careful, all right, so that you don't put it in a place. If you have multiple rules, you should be careful so that you don't put it in a place which will result in you removing files that you have already created, right? So it's something you have to be careful about when you are adding a rule like this. All right, so you should always pay attention to that. Okay, so we can proceed. So let's get back to the other terminal which is here, and then we can proceed. So now that's what we are going to do. Let's check again. So there are different ways of specifying multiple inputs. We will look at some of them. So we will start with this one. So here we specify two of them. Let's say father and then mother. So we can do that here as well. So that means we have to specify the outputs, and then Snakemake will automatically get the inputs. So we can say Snakemake that just cause 1, and then I'll say -p, and I'll say -s snake file 2 because we are still using that one. And then I can say map read slash father.bam, and I can also say map read slash mother.bam. All right, so let's execute this command. So once we do that, Snakemake will automatically get the files for us. So now it's starting with father.bam, and after that it will move to mother.bam. Okay, mapping has been done. Let's clear the screen. Let's check, and we have the output there. Right, so that is it. Now if you take a look at the documentation, it says you can also use some bash approaches for specifying multiple samples. So you can also do this. This also works. You can try that. So you can just recall it like this one here, and then you can just say map underscore reads. You bring your curly bracket, you can say father dot bam comma mother dot bam. Right, you can even do it this way. You can even say father comma mother. You bring your curly brackets like this. Let me just redo it again. I think I missed something here. I'll just redo it here. So I can just say map underscore reads like this slash. So this is how it's supposed to be. Map underscore reads slash, and then you bring your curly brackets and you say father.bam comma mother.bam, and then you bring your curly bracket like this. You can also refine it. You can just do it this way. Map underscore read slash, you bring your curly brackets, father comma mother, you close it and you say dot bam. This also works. Okay, these are bash approaches for specifying multiple samples. So that is what has been indicated here as well. So you can try this, and then you can see that one also works. Right, so anyway, let's try that quickly and then also do it. So we will try it like this. Okay, to specify multiple samples. You can also add the proband like this. That will also work like this. Okay, but with this approach, let's just try it. Let's just do this. I'll just leave it like this. So let's execute this command. All right, so if we do it, let's see what happens. All right, if you do it this way, Snakemake acknowledges the inputs. It acknowledges the information I've supplied, but we already have the files existing. That is father.bam, mother.bam. And so Snakemake will not run the commands. All right, so if you want to rerun, then that means you have to obviously remove it, or remove the file, because now you have two of them. And so that's where the other rule comes. So you can just say Snakemake +1-p -s snake file 2, and you can say clean up to remove the files. All right, so you can do that, and then clear the screen, do an ls into map, and you find that the files are gone. Then you can just redo this one. So I will leave this to you to try this approach. All right. So try it, and then you are going to find that the bound files will be generated. Right. So try it, and then let's see. Let's try it and then see what happens. Perfect. So now, because the files are not there, Snakemake will start generating the outputs, okay, based on the information I've supplied it. So let's wait for everything to get done for us. Okay, the mapping has been completed. So let's take a look at the output directory, and we can see the files there. All right. Now let's do this. Let's take a look at the fastQ directory again. Ls fastQ to see the files. Now, with the approach we use, we specified the files for the terminal like this. But then, in some cases, specifying the files or specifying the information, the inputs or the outputs on the terminal can be cumbersome. All right. So it's possible to specify the information in the snake file itself. All right. So I'm going to show you this other approach to specify all samples of interest in the snake file and then use that. So that will come in handy if you're handling multiple files. So let's do this. I want us to make a copy of the snake file. Let's do this. Let me just do this here. So I want us to do a copy. And by the way, the snake files that we are using, all of them, if you want it, just check the description box. The download to the files can be found there. All right. So let's do a CP. Let's copy snake file 2. Let's say snake file 3. We are going to edit snake file 3. Let's do an ls to confirm the file exists, and you can modify it. So this is what we are going to do. Let's first edit it like this. So the rules here, everything stays the same. We are not going to touch anything, but we will add something else. All right, so that we can iterate over the samples and then do it. So you can see I have hit the enter button. And so I'm going to add an extra rule above here. All right, so that's what I'm going to do. So this is what we are going to do. We are first going to define the samples of interest, those rates that we want to map. We will define them here. All right, so I can say this. I can just say samples equals, and I'll bring a quote like this, a Python style, not quotes. These are square brackets. Yeah, these are square brackets. We use it to define lists. For those who don't know, list is a data type in Python. I have a tutorial on that. So if you're interested, check the description box for that link. The link to that video is there. All right. So in it, we will specify the sample. So in this case, we have father, mother, proband. So I'm going to do this. I'll specify father first, so it's in quotes. So I'll say father, comma, double quotes again, mother, comma, and then proband. This is the only thing I need, right? Though we have R1, R2 for each sample, it doesn't matter. We are going to factor all that in whatever we are going to do here. All right. We already have the base command itself, so it doesn't even matter much. We will just do them here. All right. So that's what we are going to do. Now we will do this. We are going to add another rule. So that rule will complete everything for us. So with what we have, let's just look at this here. I think I will just show you now. Let's look at what we have. So with what we have, of course, we can run it. But then now we are specifying the inputs, everything in the snake file. So we have defined a list with a sample IDs. So what we have here was called run in principle. This one here. But then with Snakemake, what happens is that it tries to infer. Okay, so it tries to infer, or it tries to get all the information it needs based on what you have supplied it. So you realize that when we were calling Snakemake, we only specified the output file, and then what happened was that it's automatically and did its maths and then got the input files based on the information you have supplied in the script and then when we were about to run it. So we will add another rule, which is rule or. Okay, so rule or, this will be executed and it's first. All right, so this is the rule. So I also want you to type rule and then or and then bring your colon. And so if you have a situation like this, we use the expand function or the expand utility, if you also call it that way, to get all the input for us. So this is what we need to do. So here we are going to specify the input. The input is going to be the one we specify here, the output. Don't worry, don't get confused. Here we are going to specify the input. The inputs are going to be the output that we are going to generate from this. All right. So let me explain it. So the principle here is that we are going to supply the files that we want to generate when we call BWA map. All right. So when we supply those files here as inputs, those files do not exist. And so what will happen is that Snakemake will look for another rule that can produce that output and to execute that for us. All right. So here we are going to supply the rule or with the input that is mapped underscore reads, and then we bring the sample.bam. That's what we are going to supply here. All right. So when we supply it as input, there's an input. Snakemake expects the file to be there. The file is not there, and so it will go to the next rule, check if it can produce that file or those files for us, and then it will run that rule first to generate those files, and then those files will now be here. So it's that simple, and that's how we will get Snakemake to automate the process. But anyway, let's just start. Just follow my lead. Let's just type these things. Let's get it done, and then gradually you will get to understand the principle behind what we are doing. So first of all, we are going to use the input. We have to supply inputs. So again, you bring your input, you define it, and then the next line, you have your indentation or your indents. Then that's what you will do. You will now use the expand function to help us get the files. So we are going to use the expand function. So we have to say expand like this. Now the expand function allows us to generate a list of file names based on a template. And so in this case, this is a template. So we are going to generate a list of file names based on what we have here. There's the information samples. We have father, mother, proband. All right. So don't worry. Let's just look at it. Let's continue. So to generate it, we will have to do this. We'll bring our parentheses. Now say map underscore reads slash. I bring my placeholder for sample. And I'll say dot bam, and I'll bring my double quote again. And I'll bring a comma. I'll say, let me just close it. I'll say sample equals samples. And I'll close it like this. So this becomes our input. So what we have here, the expand will help us to generate a list of file names based on a template. And so we have the template here. So we say mapped underscore with slash sample.bam. There's a template. So that means we are going to have what? The template is specified here. We have sample equals samples. And so what this means is that we are going to have mapped underscore with slash father.bam, mapped underscore with mother.bam, and then mapped underscore with proband.bam. So the files can be found here in this directory, and we have them here. So this here, the list here, sample equals samples here means that whatever we have here, basically it's just a duplicate of the information here, but this time using what we have here. So we have the duplicates. This is the generic one, the duplicates, father, mother, proband. So the placeholder here will help us generate all that information. That's basically what the expand function does for us. And so what is happening is that we have this all right, but this input does not exist. All right, let's just look at it. Let's get back here. Let's ls into the map directory. Okay, so it's even exists here, but anyway, we will clean it. We will come back to this. Let's clean it first so that it doesn't appear. Okay, we will just remove it first. Okay, yeah, so let's ls into this. Yeah, okay, so there's it. So now we don't have it there, so we can proceed. So what we have now, this situation we have here, the BAM files, which are now the input for this rule, they do not exist. All right. If you have previously run the Snakemake pipeline, please remove the BAM file so that you have it like this. All right. So with what we have here, the BAM file do not exist. And so what will happen is that Snakemake searches for the inputs, which in this case, father.bam, mother.bam, proban.bam, all in map_root. These inputs will not be there. And so if they are not there, then Snakemake will now go to another rule, in this case, rule BWA_map, and then check if the rule can produce the outputs. That will serve as the input. Or let's say if this rule can produce the inputs that it has identified for rule all. So in this case, producing it is going to be outputs. And so here, these files do not exist, but when we come to this rule can produce those files here. They can produce those files here. So if they can produce it, then Snakemake will run this rule first to generate those files, and those files will serve as inputs here. All right. But of course, here, this is a rule, but because we don't have output and shell, it's just going to be there. It's just going to be more like it's kind of a dummy rule just to help us to generate some inputs. So some files. All right. So this rule all will help us to call this rule, and then this rule will generate the output files, which is the .bam files. So that's basically about it. So this rule here is not going to do any execution, but rather will help us to call this rule, and this rule will help us to generate the files that we want. That is the BAM file. So this is basically how the system works. All right. So we will run this. So this is the only thing we are changing. So compared to Snakefile 2 and Snakefile 3, this is the new addition. This and then this. All right. So let's edit and save changes. And then let's rerun Snakefile 3. Okay. So here we are going to run all the 3 files, or all the 3 samples. Let's ls into Pascal. We are going to rerun all the 3 samples here. But again, just make sure that you have removed all the BAM files from the directory, and then you can proceed, right? So that's what you're going to do. So let's do this. Let's call Snakemake. So I'll say Snakemake. In fact, let's do a summary first. I think that will help us. So Snakemake data summary. And I'll just say -s Snakefile 3. Let's do a summary first to get our information. So we can see them here. Okay, so there's it. Now here, let's do this. If we have files existing, then the status or plan will change. Okay, those things are, and that's also factor whether those outputs exist. All right, so anyway, we will look at all those stuffs in detail in our tutorial. So that's what's going to happen. So now let's execute this command to perform the mapping. So it's going to be Snakemake summary, not summary. Now we are not doing the summary again. So it's going to be Snakemake course 1. Now say -s Snakefile 3. All right. Now the course I'm using 1, so that means that the jobs are going to be executed one by one. But If you have a high-end PC with multiple cores, then you can use maybe 2 or 3 cores, and then you can pick it up from there. But you should note that genome mapping, depending on the size of the files, can be computationally expensive. So you need to map out the resources that will require per mapping activity, and then you can get the number of cores you need. Right? Okay. So let's do this. So now let's execute this command. Perfect. So now we can see that it's been run. So we have further R1, R2, further.bam starting, and then from there we go to the other 2 samples. So let's wait for everything to get done for us. Okay, so mapping has been done. So you will see here it says input files updated by another job. So here we are talking about the local rule all. Okay, so it says input files updated by another job. We have map reads, mother.bam, proband, further. Right? So we have generated these output files. So we can take a look at them. Let's do an ls into map reads. We are going to see the files there. All right, so there's it. Now, if we take a look at the script we use, let's say head snake file. Okay. We specify the samples here. Sometimes you can have tens of samples or hundreds of samples. So in that situation, this approach may not be the best. So there's a workaround. So if you have a situation like that, you can reach out to me and then we can look at how to do that as well. I'm also working on some scripts, some Snakemake scripts that will help you to automate your pipelines if you have multiple samples. All right, so those tutorials will be on my Patreon channel. But if you also want some tutorials on how to write pipelines with Snakemake, you can always reach out to me and we can have a session together on that. In addition to Snakemake, we also have Nextflow, which is also a workflow manager. You can also use that. And I have a tutorial that shows how to also perform genome mapping using Nextflow. So if you want to watch that, then check this video right here.